Hello students, I am Dr. Sanjeev Punia. In this unit, we discuss about the 2D transformations and window to viewport transformations till now. In 2D transformation, we discuss about the basic transformations, that is translation, scaling, rotation, reflection, and shearing, as well as we discuss about the composite transformations in 2D. In last class, we discussed about 3D transformations, and in 3D transformation, we discuss about the representation of the matrix. Then we discuss translation in transformations. From today, we will discuss about the scaling, rotation, reflection, and shearing. So we discuss about the difference in 2D and 3D. Then we discuss about the representation of 3D geometry. Then we discuss about transformations, and we study about first one, that is 3D translation, and we did one example based on 3D example also. So in today class, we will discuss from 3D scaling. So as we have seen that in 2D, when we have a point or we have an object, suppose this is object, and we have to perform a scaling on these, then the size of the object is going to be modified. Size of the object is going to be modified. Modified means either it is diminished or the size of the object is going to be enhanced. It's depend on the characteristics that how we are performing the operation on the object. This was about 2D. Now in three dimensional and in 2D we are doing the scaling on x-axis and y-axis, two axes, that is x-axis and y-axis. In 3D there are three axes, x, y and z. X, y and z means our object has three dimensional, our object is three dimensional, means it has three coordinates, so it can be scale using three dimensional object, or it can be scaled with respect to x axis, with y axis and with z axis also. So this is a process of modifying, this is a process of modifying or altering the size of the object. When we discuss about the transformation, then we discuss that there are two things those we can perform on the transformation. First one, in which the size of the object is going to be changed, and second, in which the size of the object is not changed. So in 2D scaling, size of the object is changed. So scaling may be used to increase or reduce the size. We can enhance or we can reduce the size of the object. Scaling subjects the coordinate point of the original object to change. So in this, when I have this object, and I am scaling the object, then one point, suppose this point is constant, but when I am scaling either this one is small or the large one, then other coordinates. This coordinate is also going to be changed. This coordinate is also going to be changed from here to here. So the coordinates of the object is going to be changed. Now there is a factor that is called the scaling factor. Scaling factor determines that the object is going to be enhanced in size or it is going to be decreased, that is reduced in size. It is represented by S. It is represented by S. So when scaling factor is more than one, in that case, the size of the object is increasing, and when the size of object is reducing, in it means that scaling factor value is less than 1. You can say that when the scaling factor is equals to 1, then what is happening? When the scaling factor of a scaling is 1, it means we are not performing any scaling on that object. Means the size of the object before the operation and after the operation will be same. Next, about the, now we will discuss that how the things are going to be performed and how we can find out the different coordinates. So suppose we have an object, let me draw it. Suppose we have an object, this is a 3D object where the object has some values, that is, suppose I am considering this point. Okay, instead of this I am taking, okay, this is a 3D object. Here also it will be dotted line. So suppose this is one point, this is one coordinate of the object, and the coordinate of this is on x-axis, this is x old, x old. On y-axis, this is y old. On z-axis, this is z old. Now we have to perform a scaling on x, y and z direction. Suppose the scaling on the x-axis is represented by Sx. On y-axis it is represented by Sy, and on z-axis scaling is performed by a value Sz. So scaling factor for x-axis is xz, sorry, xx. Scaling factor for y-axis is Sy, and scaling factor on z-axis is Sz. And this is the initial coordinate, that is original coordinate of object O. It is represented by x old, y old and z old as we discuss over here. So we have to find out the values of new coordinate for the object. We have to find out the values of new coordinate after applying the scaling operation on object O. Suppose I am saying that these are X new, Y new, and Z new. Suppose after applying the scaling factor, the object is suppose this one. Object is suppose this one. Then we have to find out the corresponding point of this one, the corresponding point of this one, and we will implement this for each and every point. Or what happens in the exam, they will ask about that, about a point that when we apply this operation or scaling operation on this point, then what will be the final coordinate of this point. So x new means new coordinate in x direction will be equals to x old into sx. So the value of sx can be less than 1 or it can be more than 1 when the size of the object is enhancing. On the y-axis this is y old multiplied by sy. On z-axis it is z old multiplied by sz. So it's really very simple. You have to only try to understand that what is happening when we are performing a scaling operation. So in the scaling operation on x-axis we are multiplying the value of x coordinate with scaling factor on x-axis, on y coordinate by sy, and on z coordinate by sz. So these are the way by using we can find out the values of new coordinate. Now these equations, these equations 1, 2, 3 equations, the relationship between x new and x old, we can represent this using the matrix. So matrix for this is x new, these are x new, y new, and z new. So we are going to find out the matrix of new coordinates, and based on coordinate of old matrix. So this is our old matrix. This is the matrix of new coordinates, and this is the scaling factor on x-axis, scaling factor on y-axis, and scaling factor on z-axis. I told it that why we use this one. This is for the symmetry. This is for the symmetry. Suppose I am going to solve this first line and this row, then this is sx sx multiplied by x old. This is x old plus this is 0, this is 0, and this is 0, means rest 3 are 0. So x new equals to x new equals to x old into sx. In the same way, when we will find y new, then it will be sy scaling factor on y axis multiplied by y coordinate means old y coordinate, and same on the z axis the value of z coordinate, the new value of z coordinate will be scaling factor on z-axis, scaling factor on z-axis multiplied with the coordinate of old coordinate of y-axis, old coordinate of y-axis. You can see this from the last equations that x new equals to x old multiplied by sx, y new equals to y naught, that is y old multiplied by sy, and z new equals to, so sorry, yes, I'm so sorry, this is instead of y, this is z, instead of y, this is z. Value of z coordinate, value of old z coordinate. So this is z new equals to sz into scaling factor on z axis multiplied by old values of z coordinate. So by this way we can find out the values of new x, y and z coordinates. So this is the matrix representation, and now we will do an example based on 3D scaling. Now it will be more clear to you by using this example. Now given a 3D object with coordinate points A 033, B 336, C 301 and D001, D000. Applying the scaling parameter 2 towards x-axis, 3 towards y-axis and 3 towards z-axis, and obtain the new coordinates of the object. So as I told you in the last slide that they gives the point instead of complete object, instead of complete object means suppose this is the object, then they are not asking for all the coordinates those are corresponding to this object. So whatever they are doing, they are giving any point. So in this they have given a point, b point, c point and d point, that is d coordinates, and we have to find out the new coordinates corresponding to a, b, c and d. So in this question, first we will see that what is given to us. So it's given to us the coordinates of old points, that is a old is 003, a old is 003, b old is 336, c old is 301 and d old is origin, that is 000. They give us the scaling parameter towards x means sx, this is s into x, scaling factor along x-axis, this is scaling factor on y-axis, so this is sy, and third one is scaling factor on Z axis, so this is SZ. So these values are given to us and we have to find the values of new coordinates on A, B, C and D points. We have to use these equations, those we studied earlier, to find the values of x, y and z new coordinates. But we have to apply this individually on each point, individually on point A, point B, point C and point D. So we have to perform the operations on each point separately. So point A is 033, point A is 033, Sx is 2, Sy is 3 and Sz is also 3. So we will see from here that A is 033, this is Sx, Sx equals to 2, Sy equals to 3 and Sz, that is scaling factor on Z axis, is 3. Now we have to find out, so this is 0 is corresponding to x old, this is the value of x old, 3 is the value of y coordinate and z, that is 3 is the value of z coordinate. So we have to find out the new values of x, y and z coordinates. So according to formula, it will be s new will be x old multiplied by x. So this is 0, 0 multiplied by 2, that will be 0. The new coordinate on y axis will be y new. So this will be old coordinate is 3. Scaling factor on y axis is 3. So this is 9. The coordinates of point A with scaling as z on z axis is x is z old multiplied by scaling factor on z axis. So the original value, that is old value, was 3. Scaling factor on z axis is 3. So it will be 9. So the final values of x, y, z is 0, 9 and 9. This is the coordinate of new point corresponding to A point whose coordinates are 0, 3, 3, where scaling factor is 2 on x-axis, 3 on y-axis and 3 on z-axis. So in this way we find the values of new coordinate for A. In the same manner, we have to find out the values of new coordinate for point B. So the original coordinates B, 3, 3 and 6. So value of x old, value of x old is 3. Value of y old, that is this is y old. So value of y old is 3 and value of z old is 6. Value of z old is 6. The scaling factor in x direction is 2. This is given. The scaling factor on y direction, that is on y axis, is 3 and scaling factor on z axis is also 3. So it will be 3 multiplied by 2, that is 6. 3 multiplied by 3, that is 9, and 6 multiplied by 3 is 18. So the coordinates of new point is 6, 9 and 18. This is 6, 9 and 18. So these are the new coordinates of point B. Now we will try to find out the new coordinate of point C and D in the same manner. So here you will see that the original coordinates, old coordinates are 3, 0 and 1. These are old coordinates are 3, 0, 1. The scaling factors are 2, 3 and 3 on x, y and z axis. So this will be 3 multiplied by 2 is 6, 0 multiplied by 3 is 0 and 1 multiplied by 3 is 3. So new coordinates of point C is 6, 6, 0 and 3. Now we will apply the same for Z, for D point, for point D. So the old coordinates of D point is 0, 0, 0, means the coordinate of D is at origin. The coordinate of D is at origin. So X, Y and Z old are 0. The scaling factor on X axis is 2, on Y axis is 3, on Z axis is 3. So by calculating these, this is because 0 is going to be multiplied with everything. So this is 2 into 0, so it will be 0. 0 into 3, so all 3 will be 0. All 3 will be 0. So the coordinates of new point, that is D new, after applying the scaling factors on x, y and z direction is also 0, 0, 0. When we discussing the, when we start, then I told you that the size of the object is going to be changed. The size of the object is going to be changed, but it's not necessary that size means coordinates of each and every point is going to be changed. As you will see over here, that when we are increasing the size of this object, when we are increasing the size of this object, that is 2 in x direction, so 2 in x direction, 3 in y direction, 3 in y direction and 3 also in z direction. So we are increasing this size is also 3 times, this is also 3 times, this is 2 times. So it will be, the object will be look like, sorry, this will not be here, it will be the on the axis, this will be on the axis. So let me draw. The z axis is also going to value increase 3 times. So these values are multiplied by 2, 3 and 3. So now this will be after scaling of 233, the original object changed into this object. So you can conclude it from here that one point, that is origin d is going to represent origin over here. The coordinates of d is 0 0 0. It means it represents origin, so one point of the object remains same. So here also one point, that is d, also remains same. The other coordinates of the object is changing. So the value of new coordinate of d is also 0. So if we will see this, then the coordinate of a point is going to change from 033 to 099. Point B from 336 to 6918. Point C from 301 to 603, and coordinates of D is same when we are applying a scaling factor of 2, 3 and 3 on x, y and z coordinate, x, y and z axis. So in scaling, we discussed that it's really very easy to find out the values of new coordinate when the value of old coordinates are given. Only we have to multiply the scaling factor, that is sx, sy and sz on x, y and z axis respectively. And we discuss one example also based on this. So I hope that it will be very clear from the example. So I think this is sufficient for today. In the next class, we will start rotation. Thank you.